So now we'll go on to normalization. And normalization is a process by which we decompose a relation and modify it into multiple relations, smaller relations that possess desirable properties. And so now there's different forms of normalization, and we're going to start with what we call the first normal form, 1NF. And we say that a relation is in first normal form if all the attributes are single valued. Now, this, by the way, this, if you're feeling a little cognitive dissonance about this, I understand why, because we always have that because of the way we use IEOR diagrams. And something I've been really emphasizing from the beginning is about multi-valued attributes, how they get treated both with the double circles and then converted in the conversion process into individual relations. But the rest of the world, especially someone who isn't a trained relational database designer like you, may not know that. So what they would do, as in many of your clients may do, is have these spreadsheets where they have some columns, some attributes that are intended that they can stick in multiple values. So this is the example here is the optional texts, right? That's a multi-valued attribute that got somehow made it into my design. And then what I say, the language we use is that now this whole thing violates first normal form because it has this offensive attribute in it that's not single valued. Okay, so to be in first normal form, everything has to be single valued. Now, the beauty of this is that we can now learn how to convert that, to normalize it into two relations that are both in first normal form. And we do that like this. Basically, here's what we had to begin with, R. So I'm gonna rewrite that as R1. And R1 is gonna have everything here, student ID, course ID, semester, and C title, my handwriting is usually not this bad. I think it's just the way this pen is. Student last name, major, advisor, faculty ID, faculty last name, classroom, and grade. So I plucked out this, this offensive attribute, the multi-valued attribute there, but I want that information. So what do I do? I'm going to create, let's call that 1, then we'll create this as 2. What? We'll call it, I want to be able to capture which textbooks are required for which class. So what I'm going to do is call it optional textbooks. And we'll have CID semester here, and we're going to put in textbook. Okay. Now, anyone want to notice anything a little bit fishy about that? Is that right, what I wrote down for 2? Any volunteers?
No, you could have multiple textbooks for the same class. And that,
Great. So how do I fix that, Justin? Thank you.
That's a good question. I'm not sure off the top of my head, but
okay. There it is. Good. Good, exactly. So everyone, I want you to really understand what Justin just said. He said it's a problem because he said the way I had it, and let me roll that back. When I had it like this, that's not kosher because I have one class here, and if I have multiple textbooks, well, now all of a sudden I'm going to have a violation of it's not going to be a relation because this will not be unique anymore, right? That has to be unique for every tuple in the relation. But I can fix that by making the candidate key the combination. So the combination of all three of those will always be unique for every row, okay, for every tuple. So that's how we handle it. And by the way, if you remember how you do the conversion, you do something very similar. And when you convert from EERs, remember also that I made a point about saying I didn't want these to be, that I wanted relations to be single valued, not plural, singular, not plural. But here's an exception. I do like you to put plural when it's a multi-valued attribute being converted. So that's why this says optional textbooks. And that's a clue that I'm going to be able to have a class and a textbook and have row for each of the optional texts in that class. Okay. But now when we look at this combination, this is now in first normal form. 1NF, first normal form. Okay, because it doesn't contain any multi-valued attributes. All right, so we've just performed our first example of normalization on a relation. Now we're going to go further into second normal form. And second normal form is where we're going to disallow partial dependencies. And remember what a partial dependency is? It's where something is, you have a candidate key that has elements that basically depend. Sorry, that's where you have a candidate key that you have attributes that are determined by a subset of the candidate key. So to have a subset of a candidate key, this only applies when you have a composite candidate key, where it has two or more subfields. So there's different definitions of this, and here's how we'll write it here. The first is that a relation is in second normal form if, first of all, it has to be in first normal form, and every non-prime attribute, that's attributes that are not part of the candidate key, have to be fully functionally dependent on the primary key. And remember, full was like minimal. That means that you have any other attributes, they have to depend on the whole candidate key or primary key. Now, Kent, who I mentioned briefly at the very beginning, this is an article that he wrote many years ago, and I really like his definition. He says that all non-prime attributes must depend on the whole candidate key. Okay. And then a way of saying that is that R is not in second normal form if some proper subset of a candidate key determines a non-prime attribute. And that to me is that's a much more intuitive. So I can check, if I want to check, I just look for, is there a subset of the candidate key that determines one of the non-prime attributes? So that's that, and if it is, then it's not in second normal form. And there's another definition here in the textbook, slight variation on this, and these are all equivalent, is that R is in second normal form if every non-prime attribute is fully functionally dependent on every candidate key. Okay, because that's trying to basically capture the idea that there might be more than one candidate key. All right, so let's look at this. Here we have R1. Remember, we fixed the business of the multi-valued attributes, but R1 still is not ideal. So we want to look at it and say, what else could go wrong here? Well, again, we have this idea that if we're setting up classes as we're doing right now for next semester, before students sign up, how would I put in this information about the faculty ID in the classroom plans? So this means I have this challenge with insert anomalies. And then we talked earlier about the idea of delete anomalies. If you delete all the students, you would inherently delete all the faculty and teaching records. And we talked about this also, the update anomalies, that you have to repeat all this information for every class the student takes. And here's another one, that if you change the classroom, right, as we had to do last semester, then every record must be updated carefully, right? Because the classroom is all over the place, and every single row of that table, there's a classroom. So if you change the classroom, you got to meticulously make sure you change all those lines. All right. So what we're going to do in this case is we're going to, the problem of this is that many of the non-key attributes, remember the non-key attributes are everything that's not underlined here. The non-key attributes do not depend on the whole key. So these are the non-prime attributes, and they depend on subsets of the key, the candidate key. So I want to eliminate that. I want to eliminate these are causing this to be these are causing partial dependencies. So I want to get rid of those. And so I do that by the following. I'm going to normalize that guy into second normal form. And I'll do it as follows. First, I'm going to create a separate table. I'm going to break it down into a separate table for student last name. And here I'll just put student ID and student last name. Now, if you look at that, is that in second normal form? Yes, because it only has one attribute as its candidate key. And so everything has got to be fully dependent on that. Okay, student last name depends on student ID. You can't take anything out of student ID. Next, we'll put student major. As student ID, we'll put a superscript there because it refers up to the first one. Major and advisor. And we'll do it like that because why did I underline both of those? Anyone? Come on, everybody.
The major determines the advisor and the SID determines the major. So you need both of those to determine the advisor for that student.
Close, close. Thank you, Jason. Very close. It's that, remember that a student can have two majors. Okay, that's what we're getting at. So because a student has two majors, I want to be able to have a line here for each of the majors. All right. And what's also important is that advisor is not going to depend on one of these or the other, right? Do you see why? Because advisor does not, the student may have more than one advisor. Okay, so advisor does not, a student ID does not determine advisor, and major does not determine advisor. Because a major can have more than one advisor too. Okay, so subtle point, but this is also in, these are all in second normal form. Okay, let's go on to the third one, the course. So I'll break that up so I have just CID and C title. 4, I'm going to break up the professor. So course professor, course ID, oh, course, this is going to relate to the third relation here, the semester, the faculty ID, and the faculty last name. And okay, now notice that faculty ID is determined by both of them. If I just have the course ID, it's not enough because I may have a course that's determined, that's taught by a different professor each semester. So the semester alone doesn't determine it and the course ID doesn't determine it, but together, so it's fully, faculty ID is fully functionally dependent on the course ID and semester combination. Same for faculty last name. Now I saw a note from Ali here in the questions, and students can have more than one major. Yes, absolutely. So remember that was something we talked about up here, and I'm just going to scroll back. Wait up, all the way up here. Where was it? All the way at the beginning of the lecture, this. Let's make that red. Okay. A student can have more than one major, and a student gets one advisor for each of their majors. And also note that advisors only advise in one major. Okay. Okay. So now let's go back to where we were. Don't get car sick here. All right, there we are. Now we're not done. We have to now add 5 is the course room. So here I'll take CID 3, the semester, and the classroom. Okay, that's going to tell me what classroom it's in. And then 6, we have to pick up the rest of that, the elements. I have the grade. And that's going to take the student ID 1, the course ID from 3, the semester, and the grade. And the grade depends on all of those, right? If you just have student ID, that's not going to determine the grade. And the course is certainly not going to determine the grade. So do you see why grade is fully functionally dependent on the other, on the candidate keys? Does that make sense? And classroom is fully functionally dependent on the combination of CID and semester. Okay, so all of these now are in second normal form. They're the all attributes, all non-prime attributes. Actually, let me write this in a color for you because I think that'll make it nice and clean. Let's say, let's make it green. All non-prime attributes, and that's are fully functionally dependent on the candidate key. Okay. Oh, here's another one I've missed. Oops. Yikes. Okay, so make sure you understand that. So we're building on a lot of elements that we've talked about in the class. And I know it's come up, there's been a fair amount of new material for you, but I want you to make sure you understand this, this aspect. We learned about functional dependency, then we learned about special classes of functional dependency called partial dependencies and full dependencies. And partial dependencies, as we talked about earlier, are where, or full dependencies where everything is fully dependent on the non-prime attributes in green here are fully functionally dependent on the student ID, on the candidate key. Does that make sense to everyone? All right, if it doesn't quite, if you're not quite sure about it, then go back over the notes. You can listen to this lecture again, or the key parts of it, but hopefully that'll start becoming more clear because that turns out to be very important. Now we've gotten up to second normal form.